Go.
Yay! 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 Math! Yay! Yay! Math! Yay! Yay! Yay!
One more.
Yay! Yay! Math! Yay! Yay! Math! Yay! Yay!
All right, rock on.
Woo!
Welcome to the Star Trek installment of conic sections, the Hyperbola. It's the last of the conic sections. It is the hardest of the conic sections, and I'm not speaking about how hard it is that way. I'm speaking about its difficulty.
Wait, yay, math!
Latus rectum!
That's wrong shape, but I love the latus rectum. All right, rock on.
It's out of this world.
It is. And this is a pin, by the way, so if it pricks me, don't think of me as a weak Captain Kirk.
It's upside down now. You look like
Oh.
Jetsons.
Yeah,
You should speak like William Shatner this whole class.
Here we go. So, the hyperbola. We're going to build on what we know with the ellipse.
There's not articles.
So if this were... Here we go. If this were the ellipse, let's say, no, both are squared. Or if the circle, let's say, both are squared. What is the vertex of this particular hyperbola?
0, 0,
0, 0 is the vertex, correct. All right, and now, if this were a 9 and a 4, so if the vertex or the center is 0, 0, how far left and right would we move?
3, 9,
3 left and right,
And
and 2 up and down. Okay, so similar concepts, right? But the way to tell the difference between a hyperbola and ellipse is that now we have a minus sign. Right? So we have a minus sign. Yeah. Minus. Yeah. Anyway, so it also, yeah. So this just by looking at it, we say, okay, this is a hyperbola. Both are squared, and we have a minus sign between, and there's little fractions here underneath. So hyperbola looks like this. That. Kind of like two hyperbolas or parabolas going like that. It could also look up and down. It could look like this. It could look like that too. Looks like a face. So if the x is first, meaning this part's going to be bigger than the y, this hyperbola will open to the sides. It'll open on the x. All right? And if y is first, it'll open up and down. You'll see what I mean. You'll see what I mean. All right.
You'll see what I mean.
Right. Exactly.
What?
Make me bust into a dance. Okay, so here comes the graph.
Musical edition.
Missed that.
Musical.
It's a little slanted.
High School Musical.
It's all good. So we start here. Then, where do we go? Left and right, how far?
3.
3, left and right. 1, 2, 3. 1, 2, 3. How far up and down?
2.
2. Good. 1, 2. 1, 2. Now, once we create our boundaries, we make a little rectangle, a little box. So just make a little box with a dotted line, like that. Right, Captain Kirk. This is the
More like a
porthole to the other dimension. You see? I can't see through. It's just a whiteboard. Okay. So we make our box, and now we agree that because the x is coming first, our hyperbola will open this way.
Whoa.
There's that, and that.
Wait, can you explain that again?
Sure.
It's so magic.
Wait, don't you have to draw diagonal?
We will. I got it. So, notice x minus y, right? X squared minus y squared. Meaning, the x is the dominant one. This thing has to be more than the y squared because it results in a positive number. So, because this comes first, because it's bigger, our hyperbola will open left and right because x is dominant left and right. Okay. If y came first, we would open up and down. That's the next problem we're going to do. Okay, asymptotes. Asymptotes are lines that the hyperbola will never touch. They are the diagonals of this rectangle. So please draw those. The diagonals of the rectangle are here. And the hyperbola will never touch these lines.
And what's it called?
asymptotes. I'm gonna type it. I'm gonna write that.
There's a really funny picture online, and there's this guy, and he's like, "I'm like an asymptote. You can't touch this." It was really funny.
That is good math humor. You can't hate on it.
P-T-O-T-E.
Yeah. Asymptotes.
Okay.
Yeah, it's kind of like the next. Yeah, there's lots of. Okay, yeah, we've heard that joke. Thank you. You're gonna do that at like the ice cream shop. Like, hey guys, want vanilla? Latte recto.
I'm sorry, we don't carry that flavor.
Please leave. Come again. All right. So these are the asymptotes. Now, we're going to do the equation of the asymptotes. We'll do that in a second. The foci, all right, the foci. There is an equation for that. What's the equation that you recall?
C squared equals A squared minus B squared.
Right. Now it's plus. Now it's plus.
Everything's just changing.
Right.
What is this?
So the way I remember it is that the
Cap.
ellipse had a plus here and a minus here. And the hyperbola has a minus here and a plus here. So switch the signs around.
What are we looking for?
We're looking, this C gives us the focus over here. Yeah. So the focus point over here will be somewhere in this neighborhood. And the focus over here will be somewhere in this neighborhood,
That's
correct?
a bad neighborhood.
All right, yeah, it's a good one. Don't worry, it's safe. It's safe. So let's plug in. What's A squared?
9.
9
Plus
plus 4
14.
Say it again.
equals 13. So C squared equals 13. So what's C? C is the distance of the focus is root 13 plus or minus. So C equals plus or minus square root of 13. So that means, this is what it means. From the center point, we go left and right the square root of 13.
Wouldn't it just be plus or minus 13, not the square root of 13?
It would be the square root of 13 because C squared equals 13. And let me clean this up. C squared equals 13, so C is the square root of 13. All right, and we take the square root of both sides. There we go. So this point, what are the values of these two blue points? If we started at the middle,
A little more.
So
0
X
plus
more than
square root
3.
13 and 0 minus square root 13.
More
yeah,
than
so what
3,
is that?
Less than 4.
What's this one?
More than 3, less than 4.
Right, but like the exact
0,
value.
root 13.
The other way around, X first.
Oh. Root 13, 0.
Root 13, 0. Right, we moved root 13. A distance of C we moved from the middle, and we got to root 13, 0. And what would this be?
Negative root
Negative root 13, 0. Right, so those are the focal points. Okay, and we can estimate. This point here we agreed is 3, 0. What's the square root of 13? Is it more or less than 3?
More.
More than 3. So it makes sense. It's out here. Square root of 13, 0. 3 point something. Okay. So that works. Equations of these lines. That's the last thing we have to do, and that's the hyperbola. Equation of the asymptotes. So, do you agree that there would be equations of actual lines? Right?
Yeah.
So, this is an equation of a line, and this is an equation of a line. What are the forms of lines that you know? Equations for lines. Do you know
y
them?
equals mx.
Y equals mx plus b, that's 1. We're going to use a different one though.
Oh,
AX plus BY equals.
point
That's standard, that's also 1. We're not going to do that.
Point intercept.
Point slope.
Point slope, sorry.
Point slope. Good. We're going to use point slope. It's very easy to do point slope with these two. Or it's easier to say.
Because you already have.
You have, yeah, exactly. Let's look at it. Point slope form goes like this. Y minus a point. X minus a point. So this is the basis for it.
What is this for?
This is called point slope form. And this will give us the equations of these red asymptote lines. Okay. So here's how it works. In this spot here, we have the slope of the line. The slope of the line. What's slope again? What over what?
Rise over run.
Rise over run. Very good. So here's a point. Here's a point. What's the slope of this line? 2 over 3. Thank you. 2 over 3. That's right. 2 over 3. Any questions about the slope of the line being 2 over 3? What's the slope of this line? So let's
2
do
over
it.
negative 3.
2 over negative 3 or negative 2 over 3. It's a negative slope because look, rise over run. 2 and then negative 3. So the two equations, slope is plus or minus 2 over 3. This is shorthand. This is basically saying in here are two lines. We're going to do two lines in one equation. One equation will have everything with positive 2 over 3. And the next equation will be everything with negative 2 over 3. Right? The slopes are always
Changing.
what's the word? Negative, like negate each other. One's negative, one's positive. All right, and then this slot here for the x and the y are the values of any point that's on the line. Any point that's on the line. What's the only point that's on both lines? 0, 0.
So it has to be on both points.
So it's always going to be the
On the
center.
line.
So it's always the vertex here. You put the vertex right here. So these two lines are the equations of the asymptotes. Let's clean it up. In this case, it'll be y equals plus or minus 2 over 3x. These are the two equations of the asymptotes. So again, here goes the slope. One slope will be positive, one will be negative. Here goes the vertex, because the vertex is on both lines. So it works.
Wait, where goes the vertex? Sorry.
Sorry?
Where's
The vertex are these, the numbers after y and x.
So-
We're gonna do it again.
If it's not, if the vertex isn't on 0, 0, you just do two equations?
No, just whatever the point is. Let's say the point's over here.
Oh, okay.
If the point here is like 2, negative 3, this would be y plus 3, x minus 2. All right, we'll see it done with, I wanted to make the first center at 0, 0 to start it off. All right, 2 more.
That's it?
That is the hyperbola.
So that's all we have to solve for?
Yeah, asymptotes, graph, focal points.
Oh,
That's
okay.
all. Here it comes. Y minus 3. All right. Already we know. Hyperbola minus, see? All right, here we go. So, judging by where y is, does this hyperbola open up and down, or does it open left and right?
Up and down.
Yeah.
Up and down, very good. So it's going to open up and down. Let's start that.
Why will open it up and down?
Up and down because the y value is first. It's y minus x, basically. So y is dominant. This section is bigger than
But
this.
doesn't it have to do with the number on the bottom?
Oh, no. This has to do, yeah, you're thinking about the ellipse. This has to do with how much we stretch. How much we stretch, you know? But whether it opens up and down has to do with which one comes first
How do
in
you
this
remember?
difference, in this minus. So let's find out where is the starting point.
The vertex.
Yeah, think about it.
Negative 2.
3 negative.
X
No,
first.
it's negative 2, 3.
Negative 2, 3. Good. Negative 2, 3 would be. Okay. Negative 2. Here. Okay, so this is our starting point. Negative 2, 3. Now, how far up and down are we going to go?
Up and
1.
1.
Up 1, down 1, correct?
Yeah.
Let's do it. How far left and right are we going?
2.
2 is the square root of this, right? This is the square root of 4. So it goes over 2 this way, that way. What do we do now? What do we
Box.
draw?
Make
Draw a
a
little
box.
box. Yep. Make the box. All right, good. Okay, so we're ready to draw our hyperbola now. What's it going to look like? Where does it start?
Up and down.
So it starts at these points here. All right, there's one. And there.
How do you know that they start at those specific points?
They start at these specific points every single time. The points in which you moved away from your vertex. All right. What are the coordinates of this point? Do you know? Can you tell? Negative.
Negative 2, 4?
Yeah. Negative 2, 4. It's negative 2, 4. Yes.
Isn't the x? The x is running
Left to right.
left to right, and
Yeah.
y is running up and down.
Yep.
Then why would x be up the point and y be across?
X is not up.
Yeah.
X is not up. How is X up? We went up 1 because it's Y. See, it's next to the Y. So we went up and down 1. Down 1, up 1.
And then across 4.
2. Yeah, 2 each way, making a total of 4. Yeah, 2 each way. Okay, and then we start at these points and we make our hyperbola because Y is first and it's dominant. All right, focal points, foci, whatever. Foci.
C squared equals A squared
Plus
plus
B
B squared.
All right, you got it.
Thanks for that musical intro.
You're welcome. A squared plus B squared. Okay.
Cow.
So it's 1
1
plus
plus 4.
5.
So C equals
Root
plus or
5.
minus the square root of 5.
So, both plus or minus.
Square root of 5.
So, this is important, all right? And this, we actually had this moment when we talked about the circle. We have to move plus or minus root 5 from our center point. From our center point. I'm going to mark the center point as negative 2, 3. Okay. So, the focal points will be here and here, correct? Remember?
Yeah, a little more than
little
2.
more. So, what is the value of this? What's this coordinate point? This one right here.
Square root
Negative
5.
2 square root.
So first negative 2.
Fine.
Negative 2. Okay, now what? Yeah.
Square root 5. 3.
So we start at 3. We start at 3 and we moved up how much?
So it's plus
Square root of 5. So
3
3
plus.
plus square root of 5. Yes.
How do you know to put the foci up and down?
Foci are always going to be inside your little hyperbola things.
Oh, okay.
Always inside there. Just like in the parabola. It's inside.
So then the bottom one's going to be negative 2, 3 minus square root of 5?
Yep. That's right. That's right. So here, the reason why it's 3 plus square root of 5 is that we started at 3 and went up square root of 5. And then for this guy, we start at 3 and we go down square root of 5.
Is it 3 minus root 5?
That's right. So, negative 2, 3 minus square root of 5. That's that one. Asymptotes. That's it. Draw them. Here's 1 and 2. Okay, I could have drawn this a little wider actually. Could have drawn this, and this one too. I could have drawn it wider. All right, so equation of the line for asymptotes. Now this is where.
minus
So let's put it in. Yeah. Y.
minus 3.
All right, just y minus first equals x minus. Is that in? Yeah. Okay. All right, here we
It's
go.
only just on the side.
So if that's in there, it's okay.
No, it's gonna go off.
You may want to skip the minus over it.
It's is it just
You
in?
can't see the
You
parentheses.
can. You can. There's a little space.
Okay.
Yeah.
I believe.
All right, so slope goes here. Let's do slope. Yeah. What is the slope?
No, live long and prosper.
Right. Live long and prosper, and what is the slope? So from here, how far up and how far over?
2.
Two.
No.
One.
1, 2.
1, 2.
Half
One.
3.
Negative
1/2.
1/2. Right.
1 over
1 over 2. And if it's 1 over 2, it's also what else?
1 over
Negative 1 over 2.
Right, so plus or minus 1 over 2. So here's the thing, what's so interesting, which I want to be transparent about this. The book that always has a formula and it says B over A, or A over B. Notice how that's B over A or A over B? I don't see the need in doing that formula. I would just rather look at it and make up our minds what it is exactly, instead of memorizing, oh, this is just B over A. Okay, that's the idea. So we look at our slope, 1 over 2 across, plus or minus 1/2. 1 over 2 to the left is negative. All right, now, what's the point that works for both of these green lines?
The center.
The center
2,
point.
3.
So negative 2, 3 needs to be transferred into this.
3
3 goes here,
plus 2.
3 goes here, and we have plus 2 here, right? Remember how it works in opposites with this stuff? Point slope is no exception.
Okay.
All right? Question?
It's all starting to come together from Algebra 1.
It takes, yeah, you got to bring your Algebra 1 to Algebra 2, no doubt.
So do you want us to like solve for y? So would we add 3 to both
Not necessarily,
sides?
no. It doesn't matter at this point. This is the equations
Bless you.
of, bless.
Thank you.
These are the equations of the asymptotes, right? So 3 minus 1/2.
Quick question.
Yes.
Negative 2, 3 is a point that the asymptote lies on?
Right. So remember when you suggested point slope?
Right.
Point slope means a point that's on the line and the
Right.
slope of the line.
So we're choosing a point that's on the asymptote line.
Yeah. And what's the only point that's on
That's
both
both.
lines? The middle, the center.
Yeah.
Right. And that is just simply the vertex, this thing that we got here. Negative 2, 3. One more and that's it.
All right.
One more and we're done.
I'm going to fast forward this.
That didn't take that long.
Oh yeah, we're running out of time. Let's do it. Last one. X plus 2 squared over 16 y squared over 9. Okay. I made the foci easier. Yes?
Does it always equal 1?
Yes. And if it doesn't, we've touched on this last time. If it doesn't, you have to divide both sides by this number to make this one.
Right.
Yeah. All right, let's do this right quick. Which way does this open? Up, down, or left, right?
Left, right.
Left, right. What do we do now?
Vertex.
Yes, what is that?
Negative 2, 1.
Negative 2, 1. Graphing. What do we do now?
Go to the left and right 4.
Left and right 4. To the left, to the left.
Every 4.
And then up and down 9. 3.
Good correction. All right, so 1, 2, 3, 4. There it is. And up and down 3 works.
Is it always to the left and right, like the first number? And then
For the x. No, left and right is the one under x.
Yeah, okay.
Okay.
Oh,
Because x is left and right.
got it, okay.
Good questions. And now, what do we do?
Connect, making that asymptote.
Okay, we can do that. Asymptote.
Draw your...
C squared minus equals A squared plus B squared.
Right. Drawing in. All right. Okay, we're in motor mode here.
Right. Automotive.
So here it comes. There.
Is A squared always the first number?
Yeah, it's the has to.
Automotive.
Yeah, in this case. You know, many times it doesn't even matter for me as long as you, because it's a plus function in this case. If you're adding, it doesn't matter which one's first. So that's that, and now we add them. I did this on purpose. What's a squared plus b squared?
25.
25.
C squared.
C equals 5.
So c equals plus or minus 5. So from the middle, we go 5 this way. So 5 this way would actually be here. Because we went 4 to get to this point, now we go 5 to get here. And this point is 3, 1. And this point, if we go 5 this way,
Oh.
It's 5 from
It's
the
5 from the
vertex.
middle?
5 from the middle, yes.
Okay.
5 from the middle, exactly. 5 each way. So this one is 2 minus, -2 minus 5, -7.
-7 will all
Okay? And that's it. That's it. Questions?
See you later. Yay, math! Yay, math! Yay, math! Yay, math!
You forgot the point.
This 1 equals plus or minus the slope is up
5.
up 3 over 4.
Wouldn't it be +1?
1, 2.
No,
It's
no.
1/2.
y minus.
No, it's not 1.
I mean, not 1/2.
3/4.
No, y minus 1, this implies that it's positive 1. Y minus 1 implies that it's positive 1 in
2,
point
1.
And then it's x minus 2.
X plus 2.
All right.
You know how in point slope it works in opposites. Just like, see,
So why is it
just like
plus
here
2?
it's opposite. Because it's -2. -2 for x.
Do you see what the homework is with
Yes, you
here?
do. Finish.